In this video, we will solve an example problem that involves specific gravity. And so if you want, you can pause the video here and attempt the problem. So let's get started. So we have this amount of gallons of petroleum oil, and the specific gravity of petroleum oil is 0.82, and this is being stored in a 30 feet tall storage tank. The first part of the problem, we want to know the total mass of the liquid in the tank in pound mass. And so for this problem, we first are going to want to find density. So density of the petroleum, I'm going to abbreviate it as petro. And that's going to equal specific gravity times the density of water, because specific gravity is the density of our object, which is a petroleum oil, divided by density of water. So we have specific gravity of 0.82 times the density of water will give us the density of petroleum oil. So density of water is 62.43 pound mass over feet cubed. This is something that you should have memorized. This is the density of water. And when we multiply the two, we would get 51.19 pound mass over feet cubed. And this is once again the density of petroleum oil. Now it should be the easy part, because we know that mass is equal to density, in our case density of petroleum oil, because we want to find the total mass of the liquid, which our liquid is petroleum oil. So density of petro times volume. And so density of petro was this, so we say 51.19 pound mass feet cubed, and our volume is in gallons, so we have to do some slight conversion. We could, however, say that 1 feet cubed is 12 inches cubed, and we know that 1 inch cubed is 2.54 centimeter cubed, times, we will do this in centimeters. So we can say 3 times 10 to the 5th gallons. And we know that 1 gallon is 3.785 liters, and 1 liter is 1,000 centimeter cubed. And so therefore 1 gallon is 3,785 centimeter cubed. And so once we multiply everything out, we would get 2.05 times 10 to the 6 pound mass. And now we can double check our units. So feet cubed cancels, inches cubed cancels, gallon cancel, centimeter cubed cancel with centimeter cubed, and we're left off with pound mass. So this is the first problem, and now we will do the second problem. The second problem states, what is the pressure at the bottom of the tank in pound force over inches cubed? So you can pause right here and maybe write down the question. And so for this problem, we can say that pressure is equal to the atmosphere pressure plus our density times gravity times height. And so we can say that P is equal to 14.7 pound force over inches cubed, because the question states that we want our answer in pound force inches cubed. And this is the atmospheric pressure plus density. We last calculated that density was 51.19 pound mass over feet cubed. Now in this problem, units are very important. So I'm going to want to convert pound mass into pound force. And I can do that if I say 1 pound force over 32.174 pound mass times feet divided by seconds squared. Next, I'm going to multiply by gravity. So that is 32.174 feet divided by seconds squared. And this whole thing is going to be multiplied by the height, which is 30 feet. We'll say over 1. And now let's see what we have for units. So pound mass cancels, so we get pound force, which is good because that's what we want in our numerator. Feet, this feet cancels with this feet. This second squared cancels with this second squared, because essentially this second squared could be in this numerator because we have pound mass times feet divided by second squared. So if we wanted to, we could write this right here in the numerator of this. So this cancels, and now we have feet cubed in the denominator and feet in the numerator. So this means it's essentially cancel, and this becomes a 2. So we have inches cubed, and here we have feet cubed. So we have one more step. So we can say 1 feet squared is going to be 12 inches, the whole thing squared, meaning that it's 1 feet squared divided by 144 inches squared. So once we do that, we would get, so this feet squared would cancel with this feet squared, and we would get pound force over inches squared. And once we multiply this whole thing out, we would get 25.37 pound force over inches squared. And this is the final answer for the second part. And if you wanted to just see the problem again, this was the 2 problems. First problem, we want to get pound mass. Second problem, we want to get pound force over inches squared.